I'm your host Dan Rojas, and today I am going to be showing you how to take an induction motor and convert it into an alternator. I'm also going to be talking to you about safety in regards to electricity. And what I'm going to be doing in this video, the first part I don't want you to do. I'm going to be showing you how this induction motor works, and we're going to be running the motor with the cover off and it taken in pieces, so there's a risk of getting shocked if you do something like that. I don't want you to do the first part. The second part, do with caution. The first thing that I'm going to do is talk to you about electrical safety. Now, I have an assistant off camera, Denise. She is actually standing right over there, and she has some experience in pulling a person off of an electrical circuit. That person would be me. The year was 1999, and Denise and I were doing home repairs around my mom's place, and this particular piece of conduit with the lights, which was installed by a professional electrician, was actually hot. There's a bare wire inside of there. There's not now because I pulled all the wiring out and just totally had this disconnected, but there's a bare wire in there that was touching the conduit. I was up here on an aluminum ladder, and there used to be another phone box here that had a steel post in the ground. The ladder was touching that steel post. I reached up, I was on the ladder, and grabbed that to pull myself up to work on a repair we did up there. I was soaking wet because I was sweating. I was in a full sweat. It was summertime, and water is not really what you have to worry about necessarily. Pure distilled water is a pretty poor conductor, but human sweat is made up of potassium and sodium. It is a perfect electrolyte. That's how your body works, off of those electrolytes. That's what makes your heart work. Anyways, I reached up and grabbed it, couldn't let go. When they say you cannot let go of a full voltage with 120 volt alternating current, they are absolutely correct. The stronger you are, the more your muscles contract. And I sat there for about 10 seconds trying to pull myself off of this, and everything was blurry and vibrating, and Denise had the presence of mind to come over and grab me by my shirt, and she had rubber shoes on. She was fine. She just ripped me right off of the ladder, and I landed head first against this fence right here. Boom. Now, I got up. While this was happening, there used to be a burn spot right here in the wood where my arm, I still don't touch it just because I don't like it, but there used to be a burn spot right there. Electricity was arcing over to this. I had a bruise on my leg for about 5 years. It finally went away. I immediately got up and started jogging. Now, if you get electrocuted, I'm not saying get up and jog, but my heart was acting kind of weird, so I wanted to get my heart rhythm back, so I jogged 3 miles. Long story short, I had a cardiology exam after that. I was fine. 4 years later, I had a follow-up one. That all checked out. Excellent condition. So, probably 15 seconds I was on there. Very lucky I still here in respects to that. That is why I warn you about electricity, because when you least expect it, it can knock the crap out of you. Now, the reason that this was so dangerous is that the electrician who installed it was short on his piece of ground wire. So instead of connecting the ground properly, like he should have, he proceeded to cut the ground wire off, so there was no ground to it. It was also hooked up with a reverse neutral, and we couldn't figure out, my dad couldn't remember what electrical company it was, and anyways, they were out of business. Long story, that's a whole different thing. The next thing that I want to talk to you about are these rare earth magnets that you use in the alternators. Now, these are very large ones. These are very powerful, and I personally hate these magnets because on 3 different occasions I have gotten black fingertips. What happens is the magnet smashes together, and your instinct is to pull your finger out, and as you do, it will just blacken your fingertip. Your fingertip gets numb, and that is that's if you're lucky. So what I have here is a glove, and I'm wearing eye protection because this is one of those tests that these things are just that way. So I'm going to check, make sure that we're in the pole. You can see that with my hand between it, just that. So you can imagine the closer they get together, the stronger the field. So I'm gonna, this glove has a little spongy fingertip in it. That would be your finger, Dan's finger, because it's happened 3 times. And boom. If you look, that is all the way down. Now, I cannot pull that apart just like that. So that would break your finger. If your finger was in there, you've got a broken finger. Magnetic companies actually sell these magnets that are like this big, and they have thousands of pounds of pull force. I would never, ever, ever buy one of those. A, they're $200, $300, but B, if you ever got your hand between 2 of those, I seriously doubt that any hospital in the world is going to have any experience figuring out how to get your hand out of there. So whatever goes between them is done. You could probably even crush your body right down the center, and it would be probably an instant fatality for you. So I'm not going to mess with this right now. I'm just going to stick it to the wall. And these can also shatter when they click together. I did a video on that. I haven't uploaded it yet or edited it, but it's pretty cool. When working with these, even these, let me stick this off to the side. Even these small ones, what we're going to be using for this, they are very difficult to pull apart. Now, they're not strong enough to necessarily smash your finger. If you have very soft skin, maybe they can get other very fragile body parts. They can also shatter when they click together. This is the remains of one of my larger ones. My 21-year-old nephew was over, and he picked 2 of them up. I told him, put those down, don't stick them together. Just as I said that, he put them right by his face and said, magnets, how the F do they work? Okay, funny, I've heard that 1,000 times. Boom, this happened, and it went into many, many different pieces. These will even make sparks too. I'm gonna shut the lights off and see if we can get a spark. Now these pieces aren't as strong, keep in mind, but there you go. If you're working with flammable fumes, that could ignite it. Hope I haven't scared you out of doing projects. If you're careful, you'll be okay. You might hurt yourself, but still, it's just worth noting not to do anything stupid. Now we're gonna go on to this induction motor. This is a pretty common fan. There's a guy, you'll notice this one's red. He's got them in red, white, and blue. He emailed me and got like a whole bunch of them that he wants to get rid of. They're older. They work as a fan motor. The wiring on here is a double strand, so you can do your coils. Like if you wind your own coils, you can take 2 wires and put them together to equal thicker wire. Some people like to do that because thinner wire is actually easier to wrap than a thicker gauge wire. That's the way these were done. The coil arrangements are, depending on how you look at them, counterclockwise, clockwise, counterclockwise, so on, all the way around. And induction motors do not have a magnet in them. They don't have any brushes or anything like that. What they do is the rotor inside of there has little tiny lines. The magnetic field's inducted to the center, and that's why it's called an induction motor. Now here's the part that I don't want you to do, because I'm going to be putting the cover on. You can do this, because this is just how you plug a regular motor in. But I'm going to be showing you this working. I've got putting some rubber gloves on. I'm well insulated, so you safety freaks out there, don't freak out on me. We're plugged in. And I have a switch here. I don't know if you can see that turning. I'm going to take a small magnet, stick it to the top so you can see some motion. So that's just a regular fan motor. If you take this cover off and you activate the coils, you can actually burn them up if you leave it on. Again, these are all insulated and everything. This should be fine. You might have a bare wire, and that's how you can get shocked. So here's what I don't want you to do. I'm just going to show you how these create an electromagnet. You can see how it pulls the steel in. This part right here is it's metal, so magnets stick to it. Now if you take this with the cover off and try to start this motor, it's going to just pull to one side because it's not balanced. And I have a watt meter here, and without anything in it, it's probably going to be upside down, so you'll have to use your imagination to get it back the other way. With nothing in it, you can see we jump up to 236 watts, which will heat these coils up right away and burn them up. If you do it with this in there, the same thing happens. And it locks down, and I can actually smell a warm motor. Now with the cover on, the bearing that holds this in place actually allows this to turn. So we'll put a magnet on there so you can see it and turn it on, and you'll see that it doesn't pull as many watts, which means it's going to pull less amps. So it runs at 120 watts versus the 200 and some. So you have your initial starting. Now what we're going to do is show you this running with the cover off. And that's what they look like when they're running. Now the reason that it's working, this becomes balanced in there once it picks up. This is a nice little flywheel. I'm going to disconnect our power because we're going to start messing with this. That is an AC motor. There are ways of taking induction motors, adding capacitors, some blocking diodes, a bunch of stuff, and getting them to, just like this, create a magnetic field and become a generator. The problem with that is you need a pretty decent RPM. You need to be 700, 800, 900 RPMs to get that to work. Your wind turbine or whatever you run off of this is probably not going to be that fast, which means if it's slower, you're going to lose all that. It's just going to be spinning free. So we're going to unplug this. Everything's off, totally disconnected. I'm going to pop this cover off. The reason that I like this particular setup is that the covers pop off. They are pressed on a little bit, but there's 4 bolts that hold it in place, and you can get to this in a matter of seconds with these. These coils are going one direction, counterclockwise or clockwise, depending on how you look at it. So we'll just say clockwise, counterclockwise for me. Clockwise, boom, all the way around. What you end up with is something that you can make a single phase alternator out of, because the direction of your coil matters. So you have 6 coils. So you have going opposite directions. So if you put your magnets on a piece of something like this, where you have north and south, these are both technically going to send the current. You're going to have the equivalent of these having, even though the magnets are north here and south here, because the coils are opposite directions, it's going to be the equivalent of north, north, or south, whatever arrangement. And it's going to be true if you have a magnet. If you have 6 magnets going north, south, north, south, north, south, north, south, every time it comes around, your current's going to alternate, because as the magnet slides over here, it's going to flip, and this is going to go all the way around. So you can do that with this particular one. You can have 6. This has 6 sides to it. So what I'm going to do in this video, this is just a piece of wood, by the way. I used a standard door hole saw to drill this, and I marked my spots and chopped them off so that they would match up with these magnets like so. So we're going to be testing this. This is a very quick way to show you how to do this. This is good for people who want to learn how to do this. You want to build your first alternator, don't want to spend a lot of money on it, want to understand the process, show maybe demonstrations. This is a great learning tool. It actually works pretty good. You do end up with something called cogging, because unlike the axial flux, which doesn't have the dual axial flux, which does not have a wire around an iron core like this does. Like if you wrapped the wire around this would become a magnet, an electromagnet, and the coils, as your magnets change, you would be creating alternating current that way. Like this right now, when I do this, it created a small current, so you're going to spin them really fast. The magnets have a tendency, they want to pull towards that, so that gives you some resistance as you rotate. So that actually puts drag on your wind turbine or your Stirling engine or whatever you're running this off of. Most generators that are not the dual axial flux, they experience some cogging, when you can actually get a fairly decent voltage out of this on a lower RPM. So you're gonna notice these are pretty drastically different sizes. Ideally, you would want to have perfect curved magnets that go around there that sit as close as possible, and that's gonna give you the most voltage and amps out of this. This wiring, by the way, because it's thicker, is gonna produce a lower voltage, but it's gonna give you more current. So this is gonna be far away from it, but this enables us to stack our magnets. The reason that we do that is as you stack them, your magnets stack here and you cheat the angles. So when it turns, it doesn't come around and bump into the stator part. What I did was take double stick tape. Again, this is not a permanent fix for it. You want clean double stick tape with no sawdust stuck to it. So you take your double stick tape and you wrap it around there in one continuous loop, pulling real tight. You want to make sure you don't want to get your fingerprints all over the backside, otherwise you'll mess up the stickiness of the tape. And you want to overlap it once. So we've overlapped, and without getting, we got something in there. There's a bird feather, cool. So we're overlapped there. And then now what I'm gonna do is take something that's not gonna transfer my oil to it and push it down hard. So we've got a nice initial, we have an initial sticky surface. Just like that, all the way around. These are the 1 inch by 1/2 inch small magnets. I'm gonna get this out of the way since I'm messing with magnets. I don't want it to pull over and stick. So doesn't matter which way you start. You stick one on there like this. You want to press it down nice and good. Make sure it's centered. Actually, don't press it down firmly yet. Get it positioned. Take your next one, and it will not let you stick it the wrong way. Like it'll push against you. So that's your next. You want them to go north, south, or whatever they are. So the next one, see how that works? Won't let me do it this way. This will happen, so you should wear eye protection. So we're gonna put that on there like that. Next one in place. No, you're not. That's why the double stick tape's important. It prevents it from pulling up like that. So now that all of these are in place, you want to push this down and get that tape to really hold. Ouch! Just had an ant on me. You can see this one keeps wanting to pop off. Alright, so they're all together. Now I'm going to take another layer of double stick tape and run it around the outside to crank this down. So this is just to show you a quick setup. The proper way would be to use glues or resins to hold these in place, and be patient and not try to do a video in 30 seconds or an hour or whatever. These are held in place right now, so they shouldn't come off of there, all right? So we've got just one set of magnets. Now the double stick tape for this test is important, and I'll show you why. So it spins nice and good. So we're gonna put this on there, and once you can actually get a hold of the threads with this, you can take a drill. You don't want it to go too tight or let it spin freely, because you will strip your threads out. Then reverse it. Take it all the way, actually, you don't want to go that far down. You want it to have a little, you don't want it to spin free on this, which this one just did because I've done it a few times. So ideally you'd want it pressure mounted to the shaft, but that's not going to happen. So I'm going to take a couple tiny screws and put them in there to hold it in place. There we go. So now what we're going to do is take this off. We're going to take this is a tricky part. This is why the tape is really important. If you think you're not sure about how well it holds for this particular quick setup, I'm going to put some extra tape on there because I don't want it to pull the magnets off. I'd rather have a nice sticky surface than have the magnet stick and the whole thing fall apart, like it's happened many times before. So this slides on there, and you're gonna notice it's gonna want to pull to one side. That's not a big deal. That's why you want the tape there. So you line this up where everything goes. And I use a soft piece of wood to just so you don't dent the metal. Just tap this in place. So now we're like this, and I'm gonna just get a quick voltage reading with it on the open. Ouch, I didn't close my knife all the way. So we're gonna go to alternating current. I hope you can see that. And we're good to go. So if I turn this, you can see that it should go up a little bit. I hope that's showing up. All right. Now we're gonna take our drill. Again, I'm using a drill for this. You would use an alternative energy source. A few of you posted comments, hey, you're not creating energy because your drill, I know the drill is using a lot more power than we're generating. This is just to give you a demonstration. So we got up to 10.6 volts of alternating current or thereabouts. So now what we're gonna do is we're gonna add another set of magnets. Now these are far enough away that, and they're held down good, so they're gonna overpower our stators, and we're gonna go like that. And you wanna try to not let them stick together. So we're adding a second set of magnets to it. This is gonna do two things. It's gonna increase the magnetic power that the stator has, that the rotor has, and it's also going to bring it closer to the coils on the outside. This is going to increase, it should increase our voltage and our overall power. All right, so there we go. You can see that that increased our voltage by almost double. Now for the third set, I'm gonna add a third set of magnets to this. You can't do it like this because they're too close, and you have to tape them down very good. This actually is the place where I have messed up 2 times so far, so we'll see if we can do it without screwing up the third time. So you wanna do that fast so this comes off. Now you've got this exposed. And what I'm gonna do is add another row of magnets. But first I'm gonna put some double stick tape around this set. This will give us something for the next set to grab onto. And the next one. And the next one. So now we have a relatively thick magnet there. I don't know if you can see that configuration, but it looks really good. And I'm gonna wrap this really well with, I'm using this tape, but I'm doing this so you can actually see it because it's clear. It's also thin. It's not very strong. It does snap, like you can see that it just snapped there. All right, so I'm kind of sort of confident these aren't gonna pull off. And here is why I say that it's important to do that. This fits in there a lot more snug, so when you put it on there, it jumps up and they stick very well. If they're not stuck on good, when you pull this off, they're gonna pull all your magnets off. So you wanna try to do this as gently as possible, and this is why you should use like a resin or something like that versus just cheap household double stick tape. But I'm gonna hammer this in place. Actually, it's not letting me do it because it's stuck to it. Let's see if we can pop this out without. All right, so that took me a couple minutes to do and a few choice words, but this should pop on there now. This is gonna straighten it out. The second one should be easy. I hammered that first one into place with the wooden block. So there you go. Now you've got this, and we're gonna check the voltage with the 3 magnets. So now this does cog, but if I give it a light turn, see that our voltage is higher. So now we're up to 40 volts, which is a lot more powerful. That almost doubled it. The first set was 10, the second set was 20, a double. The third set was another double, because we're getting closer to our stators, and we're also increasing the magnetic field. Again, this works both directions. The opposite direction seems to be a little bit better. For those of you that don't know what this is a bridge rectifier, and if you look on the back side, there is a plus and a minus. This is for your DC out, and there are 2 squiggly lines. This is where your alternating current goes. For the alternating current, it doesn't matter whether you hook it to the white wire or the black wire. For the direct current, you have your positive and negative, or whatever you want to call it. And this converts alternating current to direct current. These are in a lot of things. These should be heat sinked, by the way, for if you use them for really high voltage, or if you use them for a lot of power output. But what we're going to be doing is hooking this up and showing you this. Now this is nothing more than a set of blocking diodes inside put in a certain pattern. You can make those for less than $1, or you can buy these for like a couple bucks off of the internet. They're called bridge rectifiers. They come in all different sizes. You want to try to match it to your watt output. I have it mounted to a piece of wood to get it out of the way. One of the problems that you run into, some of them aren't marked on the sides. Since it's on the bottom, you can't see what's going on. The part that's got a little flat edge, there's 4 corners like a square. The part that has a flat edge right there is your positive for your DC, and the opposite, they go across ways, is negative. So your 2 alternating poles or currents would go right here. They go on these, positive, negative. Another way of knowing that you're wrong is if you put them on the DC side from the alternator, you'll get like a dead short, and you'll know that that's not right. So we've got these over here. Now I'm gonna switch this over to DC voltage, and we're gonna see what we get through the bridge over to our DC side. So now the meter is hooked up to over here to DC, to direct current. And just by hand turning it, there is a DC current there. Here we go. It's giving us over 20 volts direct current. 35 that direction. I'm gonna reverse the drill because it doesn't matter with the alternator. But this one seems to produce a little bit more power in reverse. So you don't have opposite voltage with that. Now I'm gonna power something small with this. So I have this hooked up without the meter attached. And this is a small DC motor over here. You can see it works fine. If I go the other direction, it still spins the same direction, because this is an alternator and it doesn't matter which way you go. So we have taken alternating current and converted it to direct current. I went ahead and added the bolts that come with this motor. I totally forgot about them. So that solved the problem of this falling apart. Sounds real stupid, but I forgot. Induction alternator to the bridge rectifier to a DC motor, with a little clip on the end so you can see that it spins. So here's a question for you. I have this hooked up to household AC current now with the magnetic rotor that we made inside. Do you think it will A, just sit there and do nothing? B, work good just like a regular motor? Or C, explode and blow this whole place up? Who knows? We're gonna put this on there and see what happens. Works just like a motor. And it is actually pulling 139 watts, so it is about as efficient as the rotor that came with it. So that was pretty cool. We made one of these in less than an hour. And now I have it hooked up to the alternating current to a 26 watt compact fluorescent bulb. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos.